So this is our unit circle. We are finally ready to start building this unit circle with commonly used angles. And our focus is really going to be on quadrant one. And if we can really learn quadrant one, we know a few things that allow us to figure out quadrants two, three, and four. Okay. Now, the very first thing that I need to make really, really, really clear to you is this unit circle lives in the Cartesian plane. Okay. It's not just like thrown out there. It's not just like a little beach ball bouncing around. Okay. So this really is the x-axis. Okay. And this is the y-axis. And this is very, very important. And I'm just about out of room. Hold on, there. Okay, so this really is the y-axis. Okay, now when we start filling this in, we fill in degrees, radians, and then points x, y around the circumference of this circle based on angles that are commonly used. So 30 degrees, 45 degrees, 60 degrees, and then we'll kind of play around from there. Okay, so we know that right here, we have the point, don't put 0, 1. We know that we have we have the point 1, 0, okay? And this is 0 degrees and 0 radians as well, but we're just going to start with degrees because that's easier for us. Now, if we bounce up here to the positive y-axis, we have the point 0, 1, and this happens at 90 degrees. If we go to the negative x-axis, we have the point -1, 0, and this occurs at 180 degrees. If we go to the negative y-axis, we have the ordered pair 0, -1, and this occurs at 270 degrees. And then if we do one full revolution, let's say we were drawing an angle that intersects this unit circle, and we did one full revolution, we would go right back to where we started from. So the ordered pair 1, 0, and that would be 360 degrees, okay? We need to know how to fill in these other lines, okay? And these lines don't change. They're always going to be this way for the trigonometric unit circle, okay? So if we start looking right here, if we were drawing this angle right here, well, that's actually kind of pretty, but I don't need it to be so pretty right now. So if we were drawing this angle right here, that's halfway between 0 and 90, okay? And halfway between 0 and 90 is 45 degrees, okay? Don't worry about the ordered pair. We got to do a lot of work to get those ordered pairs, okay? Now, if I look at the other two lines, it looks like they're splitting the region from 0 to 90 into thirds, and it is. So if these two lines are splitting the region from 0 to 90 into thirds, that would make this 30 degrees, and then 30 more would make this 60 degrees, and then 30 more would get me at 90 degrees. And that is absolutely the pattern. So from an axis, so in this case, the positive x-axis, you go 30 degrees, 15, 15, 30, and that takes you to the next axis. So following that pattern, let's finish navigating all the way around this circle. So if we go from this axis, the positive y-axis, we want to go 30 degrees, which takes us to 120. And then 15 more is 135. And then 15 more is 150. And then 30 more takes us to 180. So the pattern is from one axis to the next, 30, 15, 15, 30. Okay? So then from the negative x-axis, to get from the negative x-axis to the negative y-axis, we would go 30 degrees, which takes us to 210. We would go 15 more, which is 225. 15 more is 240, and then 30 more puts me at 270. Now, to go from the negative x or the negative y-axis back to the positive x-axis, we go 30, 15, 15, 30. So 270 plus 30 is 300. 15 more than that is 315. 15 more than that is 330. And then finally, 30 more than 330 puts me at that 360 that we were expecting. Okay? Now, if we needed to fill in radians, radians are always harder just because we're dealing with fractions, okay? So basically, when it comes to radians, you're going to be dealing with denominators of 6, 3, 4, and 2, okay? 6, 3, 4, and 2. And those are pretty easy to work with. So let's start with sixths, okay? Now, from 0 to pi, okay, so 0 to pi, so from the positive x-axis to the negative x-axis, let's split that into sixths. So that would be here, 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 and then finally here. So we basically skipped 45 degrees and we skipped 135 degrees. We'll get those in a moment, okay? So if we do this first one, we're taking pi and we're splitting it into 6 equal pieces. So that makes this pi over 6. That makes this 60 degrees 2 pi over 6, which if we reduce it, 2 pi over 6 is really pi over 3. Don't put 6, put 3. Okay. And then if we get to 90 degrees, that's really 3 pi over 6, which is going to simplify to pi over 2. And then if we go one more, that puts us at 4 pi over 6, which simplifies to 2 pi over 3. So this is 2 pi over 3. Now we're at 5 pi over 6. That one doesn't reduce, so this is just 5 pi over 6. And then finally we get 6 pi over 6, which we know and love as just pi. Okay? Now we're going to do the exact same thing. We're going to go from pi to 2 pi, splitting it into sixths. So we get a sixth here, 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 and then we're back to the positive x-axis. So this time we skipped 225 and 315, but I promise you we're going to get those soon. So let's keep counting. We had pi over 6, 2 pi over 6, which reduces to pi over 3 pi over 6 that reduces to pi over 2, 4 pi over 6 that reduces to 2 pi over 3, 5 pi over 6 that doesn't reduce, 6 pi over 6 that reduces to just pi. That makes this 7 pi over 6. Next, we get 8 pi over 6, which reduces to 4 pi over 3. So this is 4 pi over 3. That was 8 pi over 6. Next, we get 9 pi over 6, which reduces to 3 pi over 2. Okay. And then that's 9, so we get 10 pi over 6, which reduces to 5 pi over 3. So this is 5 pi over 3. And then we get, so that's 10 pi over 6. So this is 11 pi over 6. And then finally we get 12 pi over 6, which we know and love as 2 pi. Okay, so we filled in almost everything as degrees and radians. Now we've got to get those oddballs that we missed in the middle. So let's do those in maybe blue. Okay, so we missed 45 degrees, 135 degrees, 225 degrees, and then 315 degrees. Now, if I look here, starting at the positive x-axis, and then going to 45 degrees, and then the positive y-axis, and then 135 degrees, and then to the negative x-axis, I have split this into fourths. So I've split the region from 0 to pi into fourths. So that would make this first one pi over 4. Next, we would get 2 pi over 4, which we know is pi over 2. It's already there. Then we get 3 pi over 4, which does not reduce, so this is 3 pi over 4. Then we get 4 pi over 4, which we know and love as pi, and it's already listed. Okay, now let's do the exact same thing from pi to 2 pi. We're going to split it into fourths. So we've got a fourth here, 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 and then we get back to the positive x-axis, okay? So remember, we have pi over 4, 2 pi over 4, which is really pi over 2, 3 pi over 4, 4 pi over 4, which is just pi. That makes this 5 pi over 4. Then we get 6 pi over 4, which reduces to 3 pi over 2, which is already listed, okay? Then we get 7 pi over 4. And then finally, 8 pi over 4 is just 2 pi, and it's already listed. So understanding sixths and fourths, we were able to fill this in beautifully, okay? Now, the thirds, those just were sixths that reduced, okay? So those are like even multiples of sixths, okay? So we have filled in all of the degrees and all of the radians. The issue now is we have to fill in those really important points on the terminal side of all of those angles. So we have this point. We already know our quadrant angles. What we don't know are the 30, 45, and 60-degree angles, and then all of the others that go around the circle. Okay? So we need to figure out ordered pairs for all of these. And this all goes back to the idea of 30-degree angles, 45-degree angles, and 60-degree angles. So let's clear out a little space. So I've got my side work here. I'm going to clear it out to make some room. I need to redraw my x-axis. I accidentally erased it, but I think you all know what I'm talking about, so we'll leave it for now. Okay, so we need to remind ourselves of the 45, 45, 90 triangle. Okay, now this is in your notes from a previous section, so like 7.3 maybe. And what we found were the lengths of the two legs of the triangle each had a length of 1, and then the hypotenuse was square root 2. We also had the 30, 60, 90 triangle. And we found that the hypotenuse was 2, the length of side A was 1, and the length of side B was square root 3. And we were able to build all of the trigonometric functions based on those. So let's just look at sine and cosine, because we already know from a previous video, if we understand sine and cosine, that's our x and our y coordinate, remember from our ordered pair. But if we have sine and cosine, we can use a quotient identity to find tangent, and then we can use reciprocal identities to find cosecant, secant, and cotangent. Okay, so recall the x, y ordered pairs are really cosine theta, comma, sine theta. We found that out in a previous video. So if we were at pi over 6, that's 30 degrees, okay? So 30 degrees being right here, okay? We know that sine is going to be the opposite over the hypotenuse, okay? So that's going to be 1/2, all right? And we know that sine is really our x, or our y coordinate, okay? Now we know that 30 degrees, cosine of 30 degrees is going to be root 3 over 2, okay? Now, when you're dealing with a 45-degree angle, we know that we've got to do a little work. So let's say we're looking at this 45-degree angle right here. Well, sine is going to be 1 over square root 2. So if I had 1 over square root 2 and I rationalize it, I really get root 2 over 2. So if I look at the 45-degree angle, sine is root 2 over 2. Remember, that's always going to be our y coordinate. And then cosine is actually going to be the same thing because adjacent over hypotenuse. And then once we rationalize it, we get that same root 2 over 2. Okay? And then let's look at 60 degrees. So 60 degrees is right here. Well, if we were looking at sine of 60 degrees, that would be root 3 over 2. And hopefully that doesn't totally surprise you, and I'll tell you why in just a second. So that's root 3 over 2. And then if we're looking at 60 degrees, cosine is going to be adjacent over hypotenuse, which is 1/2. Okay? So now knowing sine, cosine of the 45, 45, 90, and the 30, 60, 90 triangles, we can fill in. We know what these ordered pairs are because we know that on the unit circle, the x-coordinate is always going to be our cosine and the y-coordinate is always going to be sine. Okay? Now, a second ago, I said that when we were looking at 60 degrees, you should have kind of known that sine of 60 was going to be root 3 over 2, and here's why. In a previous section, we talked about cofunctions and complementary angles. And what we found out is that cofunctions, so sine and cosine are cofunctions, secant and cosecant are cofunctions, tangent and cotangent are cofunctions. Cofunctions are equal when applied to complementary angles. Well, we know that 30 and 60 are complementary. Well, pretend that fits. We know they're complementary. So if I have sine of 30, that's going to equal cosine of 60. And if I have cosine of 30, that's going to equal sine of 60. All right, so that makes that really nice and easy. Okay, now what we have to do is we have to figure out what the remaining angles or the remaining points on this triangle are going to be, and they're going to follow a pattern. Okay, so when we go here, this point right here is going to match this point right here. So let me do those in blue. The only difference is now we're in quadrant two, and we know in quadrant two, sine is positive, cosine is negative. We talked about that in 7.4 when we talked about sines of trig functions. So when we do this point right here, we're going to get negative 1/2 and positive root 3 over 2. Okay? Now, when we look at, let me get another color. When we look at this point right here compared to this point right here, they're going to have the same trig functions, and it's all because of reference angles. I don't have room to draw it here, but basically, if we had this angle right here, okay, so we've got theta, which is right here, but we're interested in this little guy. Let's call it red, okay? The reference angle here would be 45 degrees. So we know what sine and cosine of 45 degrees are from quadrant one. We just need to acknowledge that now we're in quadrant two and sines are going to change. So right here, we're going to get negative root 2 over 2, comma, root 2 over 2. Now, this point right here and this point right here are going to match, but we have to acknowledge that we're in quadrant two where cosine is negative and sine is positive. Okay, so we get, in this case, negative root 3 over 2 and then 1/2. And then we can do the exact same thing. Okay, so when we do this, now this point right here, let me do it in red. So this red point right here is going to match this red point right here, but now we're in quadrant three where sine and cosine are negative. So we would get, let me erase some of my side work so we don't get confused. So now we would have negative root 3 over 2, comma, negative 1/2. Okay. This point right here is green, is going to match this point right here that's green, but we're in quadrant two where sine and cosine are negative, so we get negative root 2 over 2, comma, root 2 over 2 negative. And then finally, we've got to get blue. I've got to make sure my colors match. This point right here matches this point right here, but we're in quadrant three where sine and cosine are negative. So we get negative 1/2, comma, negative root 3 over 2. And then one more. So this blue point matches this blue point, but we're in quadrant four. And in quadrant four, cosine is positive and sine is negative. So we get 1/2, comma, negative root 3 over 2. And then we've got to go, let's see, green. So this green point matches this green point. But again, we're in quadrant four where cosine is positive and sine is negative. So we get root 2 over 2, comma, negative root 2. Shoot, I almost drew it really bad. So we get root 2 over 2, comma, negative root 2 over 2. And then finally, we've almost filled in our beautiful unit circle. We have this point right here, which matches this red point right here. And we're in quadrant four, so we know that the ratios are going to be the same, the signs are going to be different. And again, this all really comes down to reference angles, which I don't really have room to show you here, but we can have a discussion in person about that if we need to. But we're going to get positive root 3 over 2, comma, negative 1/2. Now, there are tricks for how to remember this. You definitely need to know quadrant angles, but those are pretty easy. If you can memorize quadrant one and then understand how these colorful dots work, then all you have to do is memorize quadrant one, and then you can easily fill in the rest of the unit circle. So we are going to practice, practice, practice. We're going to fill in so many unit circles that hopefully in a short time you have it pretty well memorized. But again, focus on quadrant one. If you can really focus on quadrant one and completely memorize quadrant one, and I'll show you tricks, but if you can memorize quadrant one and understand how reference angles work and how signs of trig functions work depending on the quadrant, you're going to have no issues at all. Okay, this is going to make memorizing those tables of angles and ratios so much easier. So in previous sections, we were like, hey, here's this table of all the quadrant angles and the trig functions, memorize it. And we're like, hey, here's a table with 30 degrees, 45 degrees, 60 degrees, and all the trig functions, memorize it. it's hard. This makes it so much easier. This also gives you a nice visual. Okay, so hopefully this helps. This is what we've been alluding to. We're going to use this a bunch in this course. Okay.